we're going to look at sampling. So a couple of definitions of what words mean, at least in statistics. A sample is just a small group, a subgroup of a population. And this sample, if it's a good one at least, should be representative of the population. So an example might be, I'm interested in the average age of OC students. And it's too much trouble for me to find all 6,000 of you and find out what your age is. So what I did instead is that I decided just to go to, let's pick a good one. I decided just to randomly pick 3 classes and went into those classes and got everybody's age. So the people in those 3 classes would be my sample. And I think as long as I was pretty random about it, the people in those classes would probably be very similar to everybody who goes to OC, right? They'll be young and old and so on. On the other hand, if I decided that my sample was going to be to go to the advanced weight training class in PE, and I found 50 people in the advanced weight training, and I used them to get my sample. That might not be a great sample. I don't think I'll get many 55-year-olds or even 40-year-old women or whatever, right? I'm more likely to get younger, fit people, in which case that sample isn't really a good representation of the population. So you pick a sample, it's a small group of people from the big population. You find something out about the sample that you were interested in, like their age or whatever it might be. And whatever the value you get from the sample, you can use that basically to make predictions, we call them inferences, about the full population. Now, what's a population then? It's everybody that you're interested in finding something out about. So it depends on what you're interested in. If I'm interested in the average age of OC students, then it's probably not a good idea for me to just go to the wall and find the ages of people there, because that sample, or in fact, it's coming from a bigger population, wouldn't be any good to me. So you make sure that your sample comes from a population, and you have to know who your population is. If I'm only interested in the drug usage of high school students, then I really shouldn't go and pick people who are not high school students, right? Because they would not be in that population. And what this chapter is going to be about is looking at the kinds of problems that arise out of samples. And very often what we call these things is bias. So there is bias in a sample. Means in some way, the people that you asked aren't giving you a fair representation of what that population truly is. So today is going to be a whole load of you listening to me, and because it's pretty verbal, and there's only some calculations, very minor ones at the end. Now, there is a kind of law or a rule that statisticians follow. Here it is. And it's called the fundamental rule. So it's the fundamental rule for using data. So I'm going to, you've got to remember that you are not on mute, so people will hear what you're saying.
Not taking my eyes off you.
Okay, I'm going to mute this quick before we figure out what that's about.
Someone's watching SpongeBob.
Oh, is that what that's about? Okay, so with the fundamental rule for using data, stop watching SpongeBob, although it's probably the kid, because they're at home and they have to keep them happy. So the fundamental rule for using data, oops, better get back to my screen, for making inferences. There we go. I'm going to use the word predicting because I think that makes more sense to people in English. Right. So the fundamental rule for using data for inference for predicting is that the sample you choose should be a fair representation of the population. So what that says is if you get a good sample, you can use that sample to make predictions about the entire population. So if I was interested in the drug use of students and I made sure that the sample that I used, right, the small group of students I used are pretty typical of what high school students are like, then that would be a good sample and I could then use it to make predictions about the entire population. However, if I pick a sample that's not a fair representation of the population, for instance, I'm interested in drug use, but the only people I ask are the people in track, right? The students who are, in the school teams. That group might not be a fair representation of what students are like. They're probably fitter and healthier than maybe the others are. So you have to be careful of how you choose your samples. And there's a lot of questions here about what is wrong with this sample and what is right about this sample. So one of the kind of questions that, well, it's easier because there's so much writing and I don't want you to have to write the question and the answer. If I jump over to show you some of the homework questions. Let me get a better idea of what that's like. And I'll try and change the size here if I can. Okay, nothing's being my friend here. Okay, gonna have to do something here. I'm trying to make the screen bigger. I apologize for the way, for some reason, it just doesn't want to cooperate. In case I'm just going to have to do it the best way I can. There we go, finally got one that wanted to cooperate. There. So, back to sharing. Right, you should be looking at chapter 5 sampling here, okay? Now, let's skip by a few of the early ones and look at a question, something like this. Make this a bit bigger. Yeah, again, good. A political scientist surveys 200 voters randomly selected from a list of all registered voters in a community. So let's say it's Bremerton. The purpose to estimate the proportion of registered voters who are going to vote in the upcoming election. And the question they ask, and oops, it's really annoying when it does that, gives the answer as well. I don't know, let's keep the answer. It makes it easier when I show you. I'm just gonna. Right. So what is the population of interest here? Well, since we're interested in registered voters in a community in Bremerton, the population is everybody. In this case, it's all registered voters. So the population is everyone that you're interested in. Now, let's go through all the ones. That's the right answer. Let's go through all the wrong ones and see what's wrong about them. All registered voters in the country, isn't that population bigger than what we're interested in? We're only interested in Bremerton voters. all registered voters in the community who weren't surveyed. So everybody except that 200. No, the population even includes those 200. The 200 who voted or that they looked at, those guys, actually aren't they your sample, not your population? So that's why this is the right answer. And then any single registered voter from the 200, nah. So the population is everybody that you're interested in, and that's basically it. And there's another one of the same kind. And that saved me having to write a whole load of stuff down. So I'm now going to look at things that can go wrong. And there are lots of them. So there are quite a few things that will screw up your entire process. If you get your sample wrong, then you basically, any conclusions you come to are fraught with error. I think it's a computer saying garbage in, garbage out, right? So if you ask a bad sample or you do something bad with the sample, any results you get are not valid. So one of those types of bias, it's called, is called non-participation bias. Now, what's that like? Well, that's when a large number of your sample do not answer your question. Non-participation bias only becomes important when it's a large number of people. You're going to get pretty much guaranteed some people who just won't answer you, right? You've randomly selected them and you ask them the question and they're saying, I'm too late, I don't care, I'm not going to tell you. It gets more important when that number becomes significantly large. Off the top of my head, how about 10% of the people don't answer, or worse? That then becomes a problem. I'll give you an example. Suppose you were interested in who are you going to vote for in the next election? Seems pretty straightforward question. Suppose 20% of the people say, I'm not telling you. Couldn't the reason that they are not going to tell you is because they feel some way or other that they feel, what's the word I'm looking for? They feel uncomfortable about sharing it. Try and think of an example. Yeah, if you ask people, are you going to vote for Donald Trump? Right? If Donald Trump decides to become a candidate for the next presidential election, right? Would you vote for him? Right? That kind of question. You can imagine a lot of people might not want to answer them because no would probably not cause you any grief. Would you agree if you said, no, I'm not going to vote for him? You probably won't get too much problems. If you said, yes, I was going to vote for him, couldn't that cause problems to some people? And so if you have a non-participation bias that's large enough, couldn't you say, well, of the people who answered that question, 80% said they weren't going to vote for Donald Trump and 20% said they would. But if a large percentage didn't answer, couldn't a large percentage of them also be Donald Trump supporters, but they didn't want to tell you? That would be an example of non-participation bias. If you ask some group of people on some sample, something that's very sensitive, like you ask teenage students about their drug use. Here is a list of drugs, which from this list, how many have you taken in the last month? Right, things like that. Can you imagine that you would get a lot of students who don't want to answer that? They might even lie, right? You see, that would cause a problem. If you ask married couples, have you ever been unfaithful to your partner? Can you imagine that that might cause a lot of non-participation? People don't answer it. So that is non-participation bias. Told you today was a lot of listening. Selection bias. Now, selection bias is when your sample is in some way significantly different from the general population. So selection bias happens when you pick a sample that is in some way significantly different from the general population. So let's give an example of that. Suppose I was interested in whether you were employed or unemployed, right? Whether you had a job or did not have a job. And what I did to get my sample is I went to the local mall at 2 p.m. and I asked everybody I could find in the local mall and found out if they had a job or not. Why is that sample a bad sample to do? Are the people who are in the mall at 2 p.m. on a Wednesday, are they significantly different from all the adults in the general population? What's different?
Most people who have jobs are working at 2 p.m.
Yeah, they're probably not in the mall. Does that seem reasonable? If I was interested in the drug usage of high school students, bring this one back, and I decided only to ask students who were in track, right? Would you agree that that is significantly different from the rest of the population? Wouldn't they typically be fitter and healthier students and probably don't take drugs? Because unless it's a drug enhancement, drugs tend to screw up your life, not make you run faster. So that would be another example of selection bias. Suppose I'm interested in finding out who is, who's going to win the next governor's election, because I love this type of thing when they do samples. And I decide that I'm only going to ask people in Bainbridge Island. So I'm interested who is going to be the next governor, and I only go to Bainbridge Island, and my sample is people who live there. Why would that be a problem? What's different about Bainbridge Island people compared to everybody else?
Income.
Income. From my experience, isn't there a lot of very expensive houses in Bainbridge Island, more so than here at least? And I would assume that income does have a direct effect on how you vote, right? At least there's a very good chance that that would cause bias. So can you imagine that picking your sample is probably the first major decision that you should ever do in statistics when you collect information? And you really don't want to screw this up, do you? You can also screw it up by non-participation bias, right? If you are asking something that's really sensitive and you don't get enough people to answer you, can you see then that any conclusions you make could be off by a lot? Couldn't they in fact be off by the percentage of people who didn't answer? Because maybe a lot of them would say yes or no to the question that you're really interested in. Connected to that, there's another one called response bias. And this is when people lie to you. Normally because they call it this, they want to be liked. Most people, unless you're a sociopath, in which case you don't care, want to be liked. So if you ask people questions, very often they will lie to you, because if they told you the truth, they might think that you would think badly of. So an example might be, if you went and asked a whole load of people, what percentage of income do you give to charity every year? Can you imagine that answer might be bigger than the truth? If you give 1 or 2% of your income, you might say, well, I give about 5 or 6%, right? How many people are going to say, I don't give nothing? Those people don't deserve it, right? They don't want. If you went and asked people, have you been in jail, right? Have you been sent to jail in the last 10 years? Can you imagine a lot of people in that case would say no, even although they had been to jail, right? If you're asking drug usage questions to students, high school students, couldn't they just turn around and lie to you and say, I've never taken illegal drugs, and why are you asking me? Are you going to, tell my parents if I said yes? That kind of thing. People lie to you. Response bias is a cause of problems. Very often it's connected to non-participation, because there's one of two ways to get out of this problem when the question is very sensitive. Couldn't you just say, I'm not telling you? Or you could even just lie to them to get it over with. Now, if you want to reduce or eliminate these, you do have to be careful. And there are strategies that you can use. Let me pick the drug usage of high school students, for instance, right? You wouldn't do it by just bringing the student in to a room and sit at the table with a big list and hand them it and say, okay, Johnny, will you put a cross on all the drugs you've taken this month? Can you see that would put them under extreme pressure, and they would go, you can't make me, or I'm just going to put none of the above, right? They'll lie to you. So if you wanted to get rid of these bias, a better way of tackling that problem would be to take Johnny and hand him the piece of paper and say, go into that room, Johnny, and mark in all the drugs you want. And the reason we're asking you is that we're interested in the drug usage of high school students because it's a health concern to us, and we want to know if students do overdoses, that we can tell, the paramedics, the most likely drugs that these kids are being using right now is A, B, and C, and so that it gives them information that might help save lives. Now, we don't know what you're going to put in because you don't put your name in it. And once you put your X's, you fold it up and you stick it in that box there where all the other students have done their answers, and you can give that box a good shake and nobody will know what your answers were. Can you see in that situation, you're more likely to reduce these types of biases? So if you structure it in such a way that they know why they're being asked, they know there's no repercussions to it, and there is as much anonymity as you can possibly get, you tend to reduce these a lot more. Does that make sense? And let me move on here. And let's do some examples of those 3 types of bias. So again, I'm going to, once these answers disappear, we're going to look at some questions, and you have to tell me which one of the 3 types of bias, non-participation, response bias, or selection bias. Right, that's our choices. Okay. A survey question asked of unmarried men, what is the most important feature you consider when deciding whether to date someone? And the results were found to depend on whether the question was asked by a guy or a girl. So they found out that they got different responses, right? Although it was the same question. What is the problem here?
Selection bias.
Response
Oh,
bias.
right, it's actually the response. The selection was a random group of men. I don't think they caused a problem that way. Wasn't the problem caused by the woman who was asking it? And people like to be liked. So if the woman is there and she's blonde, he might say, whoa, I like blonde women or something, right? Or he might say something like, I like them to have a sense of humor, or I like their eyes. And if you ask a guy, you might get different answers, right? About body features or whatever, right? So you can see there could be a difference caused by people like, there's a good one. If you are asking people about, let's say something like, do you think that there is still racial discrimination in the place where you live? Right, pretty sensitive question. If the person who's asking you is white and the person who's asking you is of an ethnic minority, do you know that you will get different responses? That's an example of that. Right. In a study of opinions about community issues, investigators randomly selected a sample of households and interviewed the person who answered the door. So whoever came first, they got the question. When no one was home in a selected household, a neighbour was interviewed instead. So they go to the next house and say, do you know who next door is going to vote for, right? Or whatever it was they were asking. This survey was done during the daytime hours. So households with all members working outside the home might have been missed. So your sample is only people that were in the house, or you asked for somebody next door. What's the problem with that one? From the choice of 3.
Selection bias.
Selection. Would you agree that the sample you got would not be a representative group? A lot of people who are working, for instance, unless it was a day off, would not be in that group. Third one. I hope this one is obvious. They did a telephone survey of 450 people, and 150 of them says, I'm not talking to you. That's a pretty clear one. You agree? Non-response? Now, true story. My mum's passed away now, but my mum was, she lived to her early 90s. She had a good run. And she was a very nice woman. You know, my mother wouldn't say booty mouse. And she picked up the phone, and it was a telemarketer. Do you know the ones that want to sell you windows or insurance or something? And unfortunately, by this time in her life, her hearing was very poor. And she was on the phone for 10 minutes while he did his entire spiel. And at the end of it, my mum went and said, do you know I never heard the word that you said? Could you tell me again? And the guy put the phone down instead of my mum. And I always thought that was hilarious because I was there at the time and I was just wondering who was phoning her, and she was saying, and then she finished with that. And I was thinking, that is a cool way of getting telemarketers. Do you know if they phone you during your dinner? Pick up the phone and just say, right. Don't listen to them, eat your dinner. And then at the end, when they stop talking, just say to them, do you know I never listened to a word you said? Do you want to say that again? And I think that would be a good piece of revenge. Because don't they always phone you when you don't want them to? They just have this habit. Okay, here's 3 choices, a little bit different. You know, a different way to phrase it. Participants respond differently from how they truly feel. What kind of bias is that?
Response.
Response. Right, I think I'll leave that one gone. Just pick random one of these. How about this one? A random sample of registered voters is contacted by phone and they're asked whether or not they're going to vote in the upcoming presidential election. And it could be selection bias. And the reason they're saying that is the phone survey doesn't ask people when they registered to vote. Don't know if that's true. Non-participation bias. A large number of registered voters may not be planning to vote in this election. Well, in that case, couldn't you just say, I'm not going to vote? I'm not convinced that. People may say they're going to vote, but they probably won't because they want people to think nicely of them, right? So although you could argue those ones, I'm going to go for that one. Can you see that in a couple of these questions, there's going to be a little bit of a judgment call where you think one of the other two is more important than the one that I picked? Now, I'm going to leave that for a second and talk about what's called the conservative margin of error. Right, now the conservative margin of error is only used when we are talking about you asked your sample and 22% are going to vote Republican, right? You asked your sample and 42% said that they like ice cream. So you've collected the data, but your final number is just the percentage of people who said yes to something, that kind of thing. The conservative margin of error is 1 over the square root of n, where n is the sample size. Now, what the conservative margin of error does is it gives you a range of values where you believe the true answer lies. So suppose I got a really good sample, it was nice and representative, and none of these biases had any significant effect. And I found out that in my sample, we call it p hat, you call it p hat, that's how you say that. Our sample p hat, and we got 41% of people like Rocky Road ice cream, right? So it was a very easy question for people not to lie and not participate, right? So we're comfortable with that. But this was a sample of 400 people. What the conservative margin of error conservative margin of error. Thus, in this case, it's equal to that fella. It allows us to write this down. We believe that the real answer for the population, would you agree it's very unlikely to be exactly 41? Wouldn't it be close to 41? But it's never going to be perfect. So it's plus or minus the conservative margin of error. So now I can say with a fair degree of comfort that somewhere between 36 and 46% of the population like Rocky Road ice cream. Suppose we were doing a sample on who you're going to vote for, right? And let's suppose in this case, you got the answer that 57% of them said they were going to vote for the Royalist Party. I'm picking the question, I can have that. Right. If you're interested, the Royalist Party hasn't been created yet, but if I do create it, a couple of the policies I'm going to have is, number one, I'm going to sack all the politicians because I don't need them anymore. I want the original 12 states back, right? So we have to give them back to Britain, with the exception of New York, because I don't like New York, so you can keep that one. So that's a couple of my policies. You're going to vote for those? You're going to vote for me? Yeah, I got a couple of votes, great. So let's see what the conservative margin of error says. Okay, and I ask only 100 people. Then the conservative margin of error, I'm picking numbers that are easy to work with, is 10%. So in this case, won't the range be 47, right, up to 67%? Can you see that that is a very wide range? Couldn't I win the election handsomely? 67%. Couldn't I actually end up losing the election? Because if I get 47, there's the other 53 went to the other guy, right, and he wins. Now, same result, 57% said they were going to vote for me, but I did a sample of 10,000 people. Would you agree that a sample of 10,000 people is going to be more useful, more accurate than just asking 100? And the conservative margin of error actually verifies what we kind of think. That guy, Bailey, there we go, comes out as 1%. So our confidence interval, which is what we call these, is 57, give or take 1%. In this particular case, wouldn't the newspaper article headline be, "Shock news, the Royalist Party is going to win the Bremerton election," right? Or the state election, or the national election, right? Would you agree that you're pretty confident? We'll assume that none of these errors happened, right? That we got good data. Then if the true answer is going to be somewhere between these two numbers, I'm going to win, aren't I? Yeah, does that guarantee it? Well, real life is never as clear as equations in math. Don't sometimes you do everything right, but just luck is against you. And I just happen to pick an awful lot of Royalists, in which case the other guy wins. And then people start screaming blue murder that it was fixed. You told us that the Royalist was going to win, and then the other guy won, and I don't trust you. It's pretty common that predictions that are made with all the good intentions, right? None of the politicians, right? Just good intentions, good samples, good everything. There's going to be a certain percentage of them that just get the answer wrong. That's just life. Can't avoid that. So to finish with, I'm going to give you a puzzle. And you've got to try and figure out what's wrong. Here is my heading. That's pretty bad. Seattle police are racist. And I'm going to prove it to you. You didn't know this, but Seattle police hate Scottish people. Don't hire them. Don't like them. They're racist against my race. I'm Celtic. I'm Scottish. And they did it by this. 2% of the police force are Scottish. See, look how small that number is. Told you they were racists. They hate Scottish people. Pull that argument apart. What's missing? Let's assume it's true that only 2% of the Seattle police force is Scottish. Why does that not necessarily mean that they don't like Scottish people? Something is missing. Another piece of information.
It could be that's what percentage of the population are Scottish.
Yes. Don't you need to know what percentage of Seattle are Scottish? Now, three things could happen here. Suppose 2% of Seattle is Scottish. Wouldn't that mean that's exactly what you would expect then, right? 2% of the doctors to be Scottish, 2% of the teachers to be Scottish, 2% of the police force. Now, suppose only 1% of Seattle is Scottish. What have I now found out? Only 1% of Seattle is Scottish, but 2% of the police force is Scottish. What's that telling me? That they like Scottish people more than they should. Aren't they hiring a larger percentage of Scottish people than should be in the police force? Or the least, I'm saying this from a historical thing, didn't it used to be that if you were Irish, if you went to, where was it, Boston? I think it's Boston. If you went to Boston, wasn't every second policeman Irish? Right, a lot of Irish, right, compared to other races. Now, this could also happen. 10% of Seattle is Scottish. Now, if that was true and this was true, isn't that now very suspicious? Right, there is something probably racist or whatever it is. Scottish people don't feel comfortable joining the police force, but there's a problem. So do you see that one piece of information is not always telling you the whole story? Ask yourself when the politicians, it's normally politicians that do this, say something really nasty or something really shocking, right? And they back it up with one number. Ask yourself, is there any other numbers that I should know to get a good impression of the truth here? And what politicians tend to do is they never tell you that number. They only tell you this one. And normally they don't want to tell you that number because maybe it'll contradict what they're trying to get across. Right? Make one off the top of my head. Politician might go on the TV and say, we are arresting 10% more people than we did a decade ago in our town. Right? The police are just going out there and arresting everybody they can, right? This is not good. We need to do something about this. Well, if that town had grown by 10% over that decade, is it not exactly what you would have expected, that the people who end up getting arrested for crimes has gone up by 10%? Do you see that second number is important before you start making, conclusions about what the first number is telling you? So always be aware, whenever you're told something, is there a backup piece of information? And that is us for today. Say your last name and bye-bye. We learned some cool stuff today. We learned that Seattle police don't like Scottish people, for instance. They are racist. Or maybe they're not. Okay, any questions? I'm hanging about if there is. Raven, are you good?
Sorry. So
Mhm.
I get can you hear me? Sorry.
I can, yeah.
Sorry, I get really nervous being in front of a lot of people. It's my first online class. So I was so I was looking at the notes, and sorry, you said so the 1 over the square root of the n, and the n is the sample size, right?
Yes.
That is, I don't know if you answered it. My brain was very focused on when to ask this question. But
Okay.
sorry. Is that always going to be, because you said that you made it easy numbers to help us out, right?
Yes.
Is that something that is in the future going to be say the number is the square root of 2, which is not possible.
Well, you can get the square root of 2, it'll just be a huge number.
Yeah, so how would that, can you explain to me how that would actually work?
Let's do one.
Okay.
Let's pick a small weird sample and how that would work. So I went and I asked 83 people, right? Really awkward number. And I went and asked them, do you like Pepsi?
Okay.
And I got the answer that 40% of you like Pepsi, right? And I want to see, well, I wonder what that means for the entire population, right? That's what samples are. Small group of representative people. What would that look like? Well, the conservative margin of error is 1 over the square root of 83. And so I would go 1 divided by the square root of 83. And I would round the answer off depending on the accuracy that they want. So suppose in the question they said, we want the answer to 1 decimal place, right? For instance.
Okay.
So this guy is going to be 0.1097 da 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 da. But when I round it off to 1, well, let me convert it to percentages first. So it's 10.97 da 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 percent, right? And to 1 decimal place, oh, that's interesting. That would round up. This one would become 11.0%.
Okay.
So I would just say 40%, give or take 11%, 11.0% to be exact. And you would get on one side 29%, and the other side is 51%. So your interval would still be calculated. But the margin of error would be huge, right? It'd be a big number.
Yeah. Yeah.
And because it's a big number, do you see how much there is between the smallest it might be? It might only be 29% of people who like it to more than half, right? So 29% all the way up to 51%. So you just get numbers, convert them into say a percentage and round it off. Can we pretend I did another conservative margin of error? I want to pick one, right, of 137. Right, that shouldn't come out nice. I'm trying to pick one that doesn't round off as nicely as the other one. So 1 divided by the square root of 137. Yeah, that's good. So 0.08543 da 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 da. Now, as a percentage, that ends up being 8.543%. There. That rounds off to 1 decimal place as 8.5%. So if it was this question, right, the same answer, but with a little bit different sample, we would have said it's now 40%, give or take 8.5%. This is the margin of error, right? And this is what we got from our sample. And so that would be anywhere from 31.5% all the way up to 48.5%.
Got it. Okay.
Right.
So-
Yeah, any number at all can be used, but if this number is small, won't the margin of error end up being really big?
Yeah.
And when we did, well, it's gone now, but when you make this really large, like 1,000 or 20,000 people, this becomes small. So bigger sample, smaller margin of error. That kind of makes sense. You know,
Yeah.
you ask a lot of people, you'd expect a more accurate answer.